Hello class, in this video I'm going to explain to you the concept of what we call an APR or annual percentage rate, and sometimes we also call this the effective interest rate. Now usually, for example, if you have a credit card or if you have a bank account or if you have a student loan, usually the rates published are annual rates, your yearly rates. But we have learned that the compounding period affects the growth of money. So when you have, let's say, a bank account, a credit card account, or you have a loan, it's very important that you read the fine print and understand what the compounding period is for that loan. Because as you have learned in compound interest, right, that compounding period will affect how much money you will earn if it's an investment or how much money you will pay in interest if it's a loan. So to make it a little bit easier for you to understand, let us compare the returns from two accounts. So suppose you have account number one that gives you a 10% annual interest rate compounded daily. Now, another account gives you a 10.1% annual rate, but it is compounded quarterly. So my question is, if you have $100 and you want to invest it for 1 year, which account will you choose? All right, so I'll give you a few seconds to think about this. And I hope that you have chosen the correct account. Now, usually, when we want to invest on something, right, we would think that the higher the number or the higher the rate, the better the investment is. So in most cases, people will choose the 10.1%, right, because they don't understand what compounding period means. But in this example, let's take a look at what will happen, right? So remember, in a compound interest, if you want to know your maturity value, this is the formula that you're going to use, right? F equals P, which is the principal amount, R is the rate, M is your compounding period, and P is the time. So to make the calculations easy, I've chosen P as 100. And then let's just compare it for 1 year. So the letter T that we're going to use for APRs is just 1 year, right? So for account number one, right, it will say 100, 1 plus 0.10, right? Because 10%, if I write that in decimal form, that's going to be 0.10 or 0.1. And then since it's compounded daily, I will divide that by 365. And then the MT is 365 times 1, right? So you invest it for 1 year. So actually you can take out the 1 because any number multiplied by 1 is itself, but I just put it there so you won't get confused, right? So anyway, by now I hope you understand how to put this correctly in your calculator, and if you do it correctly, it comes out to $110.52. So what it's trying to tell you is if in January 1st you put in 100, December 31st, you'll end up with $110.52. Now, account number two, on the other hand, is offering a higher rate, 10.1%, but it's only compounded quarterly. So now let's take a look at what will happen. Right, so this one will say 100, and then 1 plus 10.1% in decimal form is 0.101, and then divided by 4 because there are 4 quarters in a year, and then your exponent is 4 times 1. Again, you can take out the parentheses and the 1 because any number multiplied by 1 is itself, but I just put it there so you won't get confused, all right? And again, if you put it correctly into your calculator, it comes out to $110.49. So it's very, very clear that account number one, even if the interest rate is a little bit lower, right, is much higher. You get a much higher return, right? For each $100 that you invest, you get an extra $10.52. For account number two, for each $100 that you invest, you get an additional $10.49 in interest. So actually the APR here is the 10.52, right? The extra amount of money that you made. And this only works if we're using a principal amount of $100, right? So that's why I simplified it so you can see it easily, right? On the other hand, for account number 2, the APR is 10.49%. So the moral of the story here, class, is in your contract, it says 10% interest, right? But really, you're not receiving 10%. You're actually receiving, for account number 1, 10.52%, which is good, right? So you have an extra 0.5% additional money for your investment. Now, the bad news is, if this is a loan, right, which you will understand later on in unit 4 and unit 5, an extra 0.5% for loans, especially if it's a mortgage or loans that are large in amount, it's actually a substantial amount of money, even if it doesn't look like much. 0.5%, but if you borrow, let's say $500,000 to buy a house, it will make a huge difference. All right, so I hope this is clear, but let's have a few more examples here so you can understand it better. So in this one, the question is find the APR, or the annual percentage rate, for the following. So I have here, for example, 8.34%. That's we call it nominal rate, the rate per year. But the compounding period is every week. And then 25% if it's monthly, 25% if it's continuously. So let's do this one by one. For the 8.34% weekly compounding, right? Remember, this is our formula, and we will use P equals 100 to make our calculations simple. All right? You are free to choose any P that you want, but for me, it makes more sense to use 100 because I can see what's going on. It's very intuitive for me. All right, so then in decimal form, the 8.34 becomes 0.0834. And since it's compounded weekly, that's your M is 52. And then your exponent is 52 times 1. So go ahead and try to put that in your calculator. And hopefully we come up with the same answer. If you do it correctly, that will say $108.69. All right, so meaning my $100 will have an extra $8.69, which means my APR is 8.69%. All right. So even if it's saying, hey, your nominal rate is 8.34%, you're really receiving 8.69% in interest, which is good. If it's a loan, that's bad, right? You're paying more. All right, so what if it's 25% monthly compounding? So same formula, same principal amount, 100. The only thing different now is instead of 8.34%, we replace it by 25%. And in decimal form, that's 0.25, right? So 0.25 here. And then since it's compounded monthly, there are 12 months in a year, so then it becomes 12. All right, and then the top part will say 12 times 1. All right, so again, please try to put that in your calculator. You don't need to put the 1. And if you do it correctly, it comes out to $128.07. All right, so from $100, it will become 128.07. So I made an extra $28.07. And that's my APR, right? But instead of $1, I will just replace it by a percent symbol. So 28.07%. So as you can see, as the interest rate goes higher, right, the APR also goes higher from 25%, right? You're actually going to receive 28.07% if it's compounded monthly. That's good news because we're thinking of this as an investment. Now, usually if you have a credit card, right, and it's compounded monthly, and it says, hey, your rate is 25%, you're not really paying that. You're paying 28.07%, right? Which is very unfortunate. Now, finally, what if it's 25% compounded continuously? What is the APR? All right, now, please take note that compounded continuously has a different formula, right? The formula, I hope you watched the previous video, is PE to the RT. All right, One more time, for continuous compounding, you're using a different formula, which you have watched in the previous video. So now the letter P is still $100. The rate is 25%. So in decimal form, that's 0.25. And then the time that we're using, since it's annual, is equal to 1, right? Again, you can take out the 1. That should not matter. And if you do it correctly, I hope you remember how to put the E and the exponent on your calculator. That comes out to $128.40. So very, very close to the monthly compounding, right? How much is that? About 0.33% difference, right? So then the APR, if it's compounded continuously, is 28.40%. All right? So I hope this is clear. Later on in Unit 4 and Unit 5, we will be using these interest rates and applications such as loans or investments, and it will be very, very clear to you why we need to study these, right? But for now, let's practice how to use the formulas. Let's make sure that you know how to do this in your calculator so that when we go to the application part, right, it's smooth sailing. You understand which formula to use. You understand how to put it correctly in your calculator. And all you need to worry about is really interpret what the numbers are telling you. All right. Thank you so much. And let me know if you have any questions.